There is something deeply unsettling about an object that should not exist. Imagine holding something in your hands, something old, something worn by time, something that carries the weight of centuries in its very texture, and realizing with a slow and creeping certainty that what you are holding defies everything you thought you knew about the past. Not in a dramatic way, not in a way that announces itself loudly, but quietly, persistently. Like a question that refuses to go away no matter how many times you think you have answered it. History, as we are taught it, moves in a straight line, primitive beginnings, gradual progress. The slow accumulation of knowledge passed from one generation to the next, building upward like a cathedral stone by stone. We know where we came from, and we believe we understand the path that brought us here. But scattered across that path, buried in the earth, locked inside ancient stone, preserved in the collections of museums and private hands, there are objects and places and systems of knowledge that do not fit neatly into that story. Objects that arrived before their time. Places built with techniques that baffle modern engineers. Writing systems that appeared in isolation in places where no writing was supposed to exist. Glass that changes color like a living thing. Iron that refuses to rust after 16 centuries. Stones so massive that the mathematics of moving them still do not fully add up. What do we do with these things? There are two easy answers, and neither of them is entirely satisfying. The first is to dismiss them, to wave them away as hoaxes, misidentifications, or the product of wishful thinking. The second is to leap to the most dramatic explanation possible: ancient aliens, lost civilizations with technology surpassing our own, secret histories deliberately hidden from the public. Both of these responses share the same flaw. They stop the conversation before it has a chance to go anywhere interesting. The real answer, the honest answer, is harder and more rewarding. It requires sitting with uncertainty. It requires following the evidence wherever it leads, even when it leads somewhere unexpected. It requires the willingness to say, sometimes, that we genuinely do not know. And in a world that prizes certainty above almost everything else, that kind of intellectual honesty can feel almost radical. This documentary is about that honest reckoning. We are going to take a long, careful, unflinching look at some of the most debated artifacts and ancient sites in the world. We are going to examine the claims made about them, the outlandish ones and the reasonable ones alike, and we are going to follow the evidence as far as it takes us. Some of these mysteries have been solved, and the solutions are fascinating in their own right. Some of them remain genuinely open, defying easy explanation. And some of them occupy a strange middle ground, where the truth is more complicated and more interesting than either the believers or the skeptics have been willing to admit. We are going to begin at the very beginning, not with the oldest artifact in our lineup, but with one of the most instructive. Because the story of the first object we examine is not really a story about ancient technology at all. It is a story about how we look at things, about how desire can shape perception, about how the desperate wish to find something extraordinary can transform the perfectly ordinary into something that feels, at least for a little while, like a miracle. And from there we are going to travel through time and across continents, from the deserts of Iraq to the jungles of Bolivia, from the mountains of Lebanon to the volcanic islands of the Pacific, from the caves of ancient China to the workshops of Roman glassmakers who understood, without ever using the word, something that modern scientists would not formally describe for nearly 2,000 years. The past is not a simple place. It never was. And the further we look into it, the stranger and more magnificent it becomes. So let us begin. There is a specific kind of excitement that comes with discovery, particularly the discovery of something you were not expecting to find. It is the feeling that accompanies the moment when an amateur fossil hunter's foot catches on something in the dirt that turns out to be bone. It is the sensation a diver experiences when a shape emerges from the murk of the ocean floor and resolves itself into the outline of an amphora. It is the catching of breath, the widening of the eyes, the sudden electric awareness that the world has just become a more interesting place. For Mike Mikesell, Virginia Maxey, and Wallace Lane, that moment came in 1961, in the Coso Mountains of California, when they cracked open a geode, or what they believed to be a geode, and found something inside that, by their lights, had no business being there. Geodes are geological formations, lumps of rock with hollow interiors lined with crystals. They are the sort of thing you collect if you are an amateur rock enthusiast, which is precisely what these three individuals were. They had been searching for specimens to sell in their gift shop, and they had gathered a promising-looking lump of hardstone from a hillside, brought it back, and attempted to cut it open. Inside, instead of the glittering crystal interior they had expected, they found what appeared to be a mechanical device. There was a central core, surrounded by what looked like a porcelain sleeve, wrapped in what appeared to be a copper casing. There seemed to be something that resembled a hexagonal housing on the outside. To the untrained eye, and the eyes examining it were untrained, it looked almost impossibly like a spark plug or some kind of electrical component. But if it was a spark plug, how had it come to be encased inside what appeared to be a nodule of ancient hardened rock? What followed was a cascade of speculation that built upon itself with the speed and enthusiasm that these things tend to generate. Dating estimates were offered and picked up and repeated. Some suggested the object might be 200,000 years old. Others proposed 500,000 years. The idea began to take shape that this was evidence of a civilization far more technologically advanced than anything history acknowledged. A civilization that had existed in the distant past, built machines, used electricity, and then vanished without a trace, leaving behind only this one small, incredible relic sealed inside a stone casket. The artifact was given a name, the Coso artifact, and it was also called with the particular flair that these things attract, the geode of mystery. Photographs circulated, articles were written. The story spread through the community of people who are drawn to these kinds of anomalous findings, and it became one of the standard entries in what would eventually be known as the out-of-place artifacts category, or OOP-arts, as enthusiasts call them. Objects that exist outside the timeline where they supposedly belong. Objects that challenge the established narrative of human history. The problem, as is so often the case with these things, was that a more mundane explanation was lurking just beneath the surface of all the excitement, waiting patiently to be found by anyone willing to look for it. In the 1990s, researchers Pierre Stromberg and Paul Heinrich decided to take that look. They began by doing something remarkably simple. They compared the Coso artifact to actual spark plugs. Specifically, they examined spark plugs manufactured by the Champion Spark Plug Company in the early 20th century. The comparison was, to put it diplomatically, illuminating. The object found in the Coso Mountains matched, in virtually every particular, a 1920s-era Champion spark plug: the hexagonal casing, the porcelain insulator, the central electrode, the threading. Everything corresponded to a manufactured spark plug from the early decades of the 20th century. But then a second question arose, and it was a fair one. If this was a modern spark plug, how had it come to be encased in what looked like solid rock? The answer lies in a natural process called a concretion. A concretion is a hardened mass that forms around an object, any object, when minerals in the surrounding sediment gradually cement themselves together over time. Process does not require millions of years. Depending on the specific conditions of moisture, mineral content, and chemistry, a concretion can form around an object within decades. A spark plug lost or discarded in the Coso Mountains sometime in the 1920s or 1930s could very plausibly have been encased in a hardened mineral shell within the 40-odd years between its presumed discard and its discovery in 1961. The mystery, examined carefully, dissolved. What remained was a lesson, one of the most important lessons that the study of anomalous artifacts has to teach. Extraordinary claims require extraordinary evidence, and the first step in evaluating any claimed anomaly is to ask whether there is a simpler explanation that has been overlooked. In the case of the Coso artifact, there was a straightforward one, a mundane one. One that required no revision of the historical record, no positing of ancient advanced civilizations, no accommodation of the impossible. But here is what is interesting about that lesson, because it cuts in more than one direction. The debunking of the Coso artifact does not mean that every anomalous artifact is a fraud or a misidentification. It does not mean that every claim of out-of-place technology is wrong. What it means is that the tools of skeptical inquiry, careful comparison, attention to simpler explanations, willingness to revise initial impressions must be applied consistently. And when those tools are applied to other objects on our list, the results are considerably more complicated, because for every Coso artifact there is a Lycurgus cup. For every debunked spark plug in a rock, there is a Roman glassmaker who somehow understood nanotechnology. The world of anomalous artifacts is not uniformly fraudulent, and it is not uniformly genuine. It is a mixed landscape that requires navigation, and navigation requires that we keep our instruments calibrated. So let us calibrate them and move on to Iraq. Sometime around 1936, in the village of Qujat Rabu, located near the ancient city of Ctesiphon in what is now Iraq, workers excavating an old site unearthed a collection of small clay jars. The jars themselves were not particularly remarkable in appearance. They were the sort of vessel that the ancient world produced in enormous quantities, simple and functional and unremarkable at first glance. But one of these jars, when examined closely, revealed something unexpected inside. The jar was roughly 14 centimeters tall. It was sealed with an asphalt stopper. Through the stopper, a copper cylinder had been inserted, closed at one end with an asphalt seal. Inside the copper cylinder was an iron rod. The iron rod and the copper cylinder did not quite touch. There was a small gap between them, maintained by the asphalt seal. And this gap, this careful separation of two different metals within a clay vessel, was what gave the object its peculiar significance. Wilhelm Koenig, an Austrian archaeologist who was working at the time as the assistant director of the National Museum of Iraq in Baghdad, came across these jars and was struck by a sudden and intriguing thought. The configuration of the iron rod inside the copper cylinder inside the clay jar was, to his eye, structurally similar to something he recognized from the modern world. It looked, he thought, like a simple electrical cell, like a battery. If you were to fill that jar with an acidic liquid, vinegar, say, or fermented grape juice, the chemical interaction between the iron rod, the copper cylinder, and the acid would generate a small but measurable electrical potential difference. In plain terms, it would produce electricity, not much electricity, not enough to power anything sophisticated, but enough to measure, enough to be real. Koenig published his theory in 1940, suggesting that these ancient jars might have been used as galvanic cells, primitive batteries, possibly for the purpose of electroplating metal objects with a thin coating of gold or silver. This idea was tested in 1978 when a German Egyptologist named Arne Eggebrecht constructed a replica of the Baghdad battery, filled it with grape juice, and used the electricity it generated to electroplate a small silver statuette with gold. The process worked. The replica battery produced about half a volt of electrical potential, which was sufficient to accomplish the electroplating in a short period of time. The demonstration was striking, and it gave the Baghdad battery theory a considerable boost in popular culture. Here, it seemed, was evidence that the ancient Parthian people of Iraq, or perhaps their Sassanid successors, since the dating of the jars places them somewhere between 250 BCE and 640 CE, had understood the basic principles of electrochemistry more than 1,000 years before Alessandro Volta constructed his famous voltaic pile in 1799. The implications were dizzying. If ancient peoples in the Middle East had batteries, what else might they have had? And if they had batteries, why did that knowledge apparently disappear without leaving a clearer trace in the historical record? Those are the questions that the battery enthusiasts ask, and they are legitimate questions. But the case against the battery theory is also legitimate, and it is worth examining with equal care. The primary objection is one of context. While we can demonstrate that the Baghdad battery could function as an electrical cell, we have no direct evidence that it was ever used that way. Archaeology is full of objects that can be repurposed or reimagined by later observers. The question is always what the original makers intended and how they actually used their creations. And here, the evidence becomes thin. There is no ancient text, no inscription, no wall painting, no surviving artifact that depicts these jars being used in a way consistent with electroplating or any other electrical application. The jars were found as part of a larger collection of objects, many of which were clearly storage vessels, and the internal components, the copper cylinders and iron rods, could potentially have served entirely different purposes. Some scholars have proposed that the jars were used to store sacred scrolls, with the metal components serving to protect the contents from moisture or pests. Others have suggested that the internal structure served a ritual purpose that we no longer have the context to understand. And still others have pointed out that the technology of electroplating was not unknown in the ancient world through other means. Mechanical gilding, amalgam processes, and other techniques for applying thin layers of precious metal to objects were available and documented, raising the question of whether a battery would have been necessary even if craftsmen had wanted to electroplate objects. So where does that leave us? The Baghdad battery occupies an interesting epistemic position. It's not debunked in the way the Coso artifact was debunked. The original claim that ancient people had some kind of electrical device has not been definitively refuted. What we can say is that the evidence for that specific use is circumstantial, that alternative explanations exist, and that the historical context does not clearly support the battery interpretation. It is a genuinely open question, and genuinely open questions are rare and precious things in the study of history. They deserve to be held carefully, neither forced into a definitive answer nor dismissed because they make us uncomfortable. From the deserts of Iraq, we move to an object that seems, on the surface, to be even more straightforward, and yet which carries with it a set of implications that are considerably more complex than they first appear. In 1934, a woman named Emma Hahn was hiking along the Red Creek near London, Texas, and yes, I recognize I just used a place name, so let me rephrase. A woman named Emma Hahn was walking along a creek bank in a remote rural area when she noticed something sticking out of a sandstone ledge. It was a piece of what appeared to be wood, but embedded in what was clearly solid rock. She and her husband, Max Hahn, noted the curious find and returned later to collect it, eventually cracking open the surrounding stone to reveal the object inside. What they found was a hammer, a completely ordinary-looking hammer with an iron head and a wooden handle, of the type that a 19th century or early 20th century craftsman might use. The head was about 15 centimeters long and just over 2 centimeters in diameter. The wooden handle was still partially attached and had undergone a process of partial coalification, meaning it had begun to turn into coal, which suggested long exposure to specific geological conditions. This object, which became known as the London Hammer after the town of London in Texas where it was found, was eventually acquired by Karl Baugh, a creationist minister who became one of its most prominent promoters. Baugh claimed that the hammer was hundreds of millions of years old, based on the argument that the Ordovician-era limestone formation in which it appeared to be embedded was that ancient. If this were true, it would mean that a modern-looking hammer had existed during the Ordovician period, a time when the most complex life forms on Earth were primitive marine invertebrates. The implications for conventional geology, for evolutionary biology, and for the entire accepted timeline of human history would be catastrophic. Baugh used the London Hammer as a centerpiece of his creationist museum and as one of his key arguments against the scientific consensus on the age of the Earth. But geologists who examined the claims found a much more mundane explanation, one that did not require any revision of the geological timescale at all. The key insight is the distinction between the age of the surrounding rock and the age of the object inside it. The fact that an object is found embedded in old rock does not mean the object is as old as the rock. Concretion formation, the same process we saw with the Coso artifact, can cause modern objects to become encased in rock like mineral deposits within a human lifetime. What appears at first glance to be a hammer embedded in hundreds of millions of years old limestone can, in reality, be a 19th century hammer that fell into a crack or a crevice and became encrusted with mineral deposits over the course of decades or a few centuries. Moreover, geologists who examined the site pointed out that the rock in the immediate vicinity of the hammer was not clearly part of an ancient Ordovician formation, but was rather a kind of local nodular concretion that had formed more recently. The Ordovician rock in the area is genuine, but the hammer was not necessarily embedded within it. It was embedded within a younger concretion that happened to be lying in proximity to older geological material. When the hammer head itself was analyzed, the composition of the iron was found to be consistent with iron working techniques from the 19th century, not with anything that would suggest extreme antiquity. The evidence, taken together, points strongly toward the London hammer being a relatively recent manufacturing artifact, perhaps a couple of hundred years old, that became encased in a mineral concretion over a period of decades to centuries. Once again, the mystery dissolves under scrutiny. But once again, something valuable remains after the dissolution, because the process by which ordinary objects become encased in rock, by which the natural world mimics the appearance of ancient burial, by which the passage of time and the movement of minerals can transform the recent into something that looks immeasurably old, that process is itself remarkable. It tells us something important about how we read the physical world. It tells us that appearances, especially geological appearances, can be deeply misleading. And it reminds us that the most important question an investigator can ask is not, what does this look like, but what could have caused this, and which of those possible causes best fits all the available evidence. Now we come to a story of a very different kind. Not a story of misidentified geological formations or mistaken dating, but a story of something that appears, at closer examination, to be significantly more troubling than a mere misidentification. A story of claims so thoroughly unverifiable that the question is not really about ancient mysteries at all, but about the nature of evidence and about what happens when that evidence is absent entirely. The Dropa stones are perhaps the most dramatic entry in any catalog of anomalous artifacts. The story, as it has been told in various books and articles since the late 1960s, goes something like this. In 1938, a Chinese archaeologist named Kai Pute led an expedition into the mountains of the Bayan Har Range on the border of China and Tibet. In a remote cave complex, the expedition allegedly discovered a series of graves. The remains in those graves were small and delicate beings with large, oversized heads and slender, fragile frames. Alongside the graves were stone discs, roughly 30 centimeters in diameter, with a hole in the center and a groove spiraling outward from the hole in a manner that evoked a gramophone record. There were allegedly hundreds of these discs. The story continues with decades of attempted translation. The spiral grooves were eventually interpreted as a form of writing, tiny, microscopic inscriptions that allegedly told a remarkable tale. According to the translations attributed to various scholars over the years, the discs recorded the story of a people called the Dropa, who had come to Earth from another star system 12,000 years ago. Their spacecraft had crashed in the mountains, and many of them had been killed. The survivors had been unable to return home and had been forced to integrate, sometimes violently, with the local human population. The large-headed graves were, in this telling, the mortal remains of the crash survivors. It is a compelling story. It is the kind of story that, once heard, is difficult to dismiss entirely because it lodges itself in the imagination and asks to be believed. It has the texture of mythology, the intimacy of a found document, the grandeur of an ancient tragedy spanning the stars. It is, in other words, a very good story. It is also, as far as anyone has been able to determine, entirely unsupported by verifiable evidence. When researchers and journalists began attempting to trace the story to its sources, they encountered a series of blank walls. The archaeologist Kai Pute, no verifiable record of his existence. The scholars who allegedly translated the discs, their identities shift, their affiliations are unverifiable, their academic papers are untraceable. The museum in China where the discs were supposedly housed, no curator, no curator's records, no catalog entry that corresponds to the described collection. Photographs of the discs exist, but their provenance is unclear and disputed. No independent scholar has ever examined an actual Dropa stone. No institution has confirmed their existence. The story appears to have originated, or at least been significantly amplified, through a series of publications in the late 1960s and 1970s, in particular through the work of writers who were, at that time, constructing a broader narrative of ancient alien contact with Earth. The Dropa stones fit perfectly into that narrative, and they were incorporated into it eagerly. But the documentary foundations of the story, the archaeological expedition records, the university affiliations, the museum acquisitions, the scholarly papers have never been produced. This does not mean with absolute certainty that nothing was ever found in those mountains. It is possible in theory that there were unusual artifacts discovered in remote cave systems, and that the story was subsequently distorted and embellished beyond recognition by those who repeated it. Archaeological expeditions to remote regions in the 1930s are not always well documented, and there are genuine gaps in the historical record of that period in that region. But the responsible conclusion, given the evidence as it stands, is that the Dropa stones as described, the alien crash narrative, the microscopic writing, the skeletal remains of extraterrestrial beings, cannot be accepted as historical fact. The story lacks the evidential foundation that even a modest historical claim requires. In the taxonomy of anomalous artifacts, the Dropa stones sit in a category of their own, not a misidentified real artifact as the Coso artifact was, but a story that may lack an artifact at all. The Dropa stones are important, however, not because of what they reveal about the past, but because of what they reveal about us. About the human hunger for a deeper history, for the sense that the universe has been paying attention to us for longer than the conventional record suggests. About the way that hunger can, when it meets a compelling story in the right cultural moment, override the ordinary instincts of skepticism. About the particular potency of ancient alien narratives in an age when the cosmos had just become, through space exploration and radio astronomy, a place that might actually contain other minds. We want to be visited, we want to matter on a cosmic scale, and sometimes that wanting shapes what we believe we have found. There are some artifacts, however, where the debate is genuinely more balanced, where the object itself is real, verifiable, and physically present, but where its origin and interpretation remain legitimately contested. The aluminum wedge of Aiud belongs in this category, and its story is worth telling carefully. 1974 in Romania, workers digging along the banks of the Mureș River near the city of Aiud, at a depth of approximately 10 meters, unearthed 3 objects. 2 of them were the bones of a mastodon, a large, elephant-like creature that went extinct at the end of the last ice age, roughly 10,000 years ago. The 3rd object was a piece of aluminum, roughly 20 centimeters long, shaped something like a wedge or a hammerhead, with various holes and concavities in its surface. The object was coated in a layer of aluminum oxide, the kind of patina that forms on aluminum over long periods of exposure. The object was sent to institutes in Cluj-Napoca for analysis, and the material composition was confirmed as aluminum. The specific alloy was determined to contain approximately 12% silicon, along with traces of copper, zinc, lead, tin, zirconium, cadmium, nickel, cobalt, bismuth, silver, and gallium, a complex metallurgical composition. Now here is where the interpretation becomes genuinely interesting. Aluminum in its pure or alloyed form is not found naturally. The element aluminum is the most abundant metal in the Earth's crust, but it does not exist in nature as metallic aluminum. It is always chemically bonded with other elements, primarily in compounds like bauxite. The process of extracting metallic aluminum from its ore is an industrial one, requiring significant technology. The Hall-Héroult process, which makes aluminum production economically viable, was not developed until 1886. Before that, aluminum was so difficult to produce that it was actually considered a precious metal, more valuable than gold, and was treated as such by the wealthy and powerful who could afford small amounts of it produced by laborious chemical reduction methods. If the aluminum wedge of Aiud is genuinely as old as the mastodon bones found alongside it, 10,000 or more years old, then we are faced with a profound problem. How did someone 10,000 years ago produce metallic aluminum? That would require an understanding of aluminum chemistry and a technology for extracting it from ore that, by everything we know about the ancient world, did not exist. But there is another possibility, and it is the one that most scientists and archaeologists consider most likely. The object was simply deposited in the soil at a much later date and happened to come to rest near bones that were far older. This kind of stratigraphic mixing is not unusual. Objects from different time periods end up in close proximity all the time, through natural geological processes, animal activity, flooding, erosion, and human disturbance of the soil. Finding two objects at the same depth does not guarantee they are the same age. The physical dating of the aluminum itself has also been debated. The layer of aluminum oxide on the surface, the patina, has been used to argue for great age, on the basis that it would take a very long time to develop. But aluminum oxide forms at different rates depending on environmental conditions, and a thick patina on an aluminum object does not necessarily imply thousands of years of exposure. It could imply decades of specific chemical conditions. There is also the matter of the object's shape. Various observers have described the aluminum wedge of Aiud as resembling a landing foot, a bracket, or a component from some kind of vehicle, and this description has fed speculation about its possible origin. In the most dramatic interpretation, it is a piece of alien technology that arrived with or near the mastodon bones. In more grounded speculation, some have suggested it resembles certain aircraft components. In the most conservative interpretation, it is simply a piece of aluminum of uncertain age and purpose, found in a context that does not cleanly determine its origin. The Romanian government has not made the object easily accessible for independent scientific analysis, which has unfortunately added an additional layer of mystery and suspicion to the story. What we can say with confidence is this: the object is real. It is composed of aluminum alloy. It was found in a location that makes its origin puzzling on the surface, and its true age and purpose remain, as of this writing, genuinely uncertain. It is one of those objects that sits stubbornly in the middle ground, too real to dismiss, too ambiguous to declare solved. We are going to spend a considerable amount of time with our next subject because it deserves that time. It is not flashy in the way that some of the artifacts we have already discussed are flashy. It does not carry the immediate visceral impact of a hammer in a rock or the alien glamour of the Dropa stones, but it is in many ways the most intellectually rich and historically significant mystery in our entire catalog, because it is a mystery about language, about writing, about the very capacity of human beings to encode meaning in marks and symbols. And because recent scientific advances have begun to shed new light on it in ways that are both surprising and deeply moving. We are talking about the Rongo tablets of Easter Island. Easter Island, or Rapa Nui, as it is known to its indigenous people, is one of the most remote inhabited places on Earth. It sits in the southeastern Pacific Ocean, roughly 3,700 kilometers from the coast of Chile and about 2,600 kilometers from the nearest island with a resident population. It is a small island, roughly 160 square kilometers in area, formed by volcanic activity and shaped by the wind and the sea into a landscape that is stark and beautiful and strange. It is most famous in the wider world for its moai, the enormous stone figures, hundreds of them, carved from the island's volcanic rock and placed on ceremonial platforms around the island's coast, their backs to the sea, their vast faces staring inland with an expression that manages to be simultaneously impassive and somehow watchful. But the moai, remarkable as they are not the mystery that concerns us here. What concerns us here is something smaller, something that can be held in a pair of human hands, something that was found in the 19th century and has defied interpretation ever since. The Rongo tablets, or more precisely, the Rongo inscriptions, since the medium includes not just flat tablets but also staffs, a Riamiro breast ornament, and a small figure, are objects inscribed with a distinctive system of symbols. The symbols themselves are stylized, elegant, often depicting human figures, birds, plants, geometric forms, and other elements in a manner that is clearly systematic and clearly meaningful. They are arranged in lines, and they are read in a manner called reverse boustrophedon. You read one line from left to right, and then you turn the object upside down and read the next line from what is now the new left to the new right. The reading direction alternates with each line, and the orientation of the figures rotates accordingly. This is a consistent, deliberate, systematic arrangement. It is not random. It is not decorative in the way that pure ornament is decorative. It has the structure of writing, or at least of a sophisticated mnemonic system, and yet no one has been able to read it. The story of how the Rongo tablets came to the attention of the wider world is itself a story of tragedy and destruction. When the first European visitors arrived at Easter Island in the 18th century, the island's culture was already under severe stress from a population collapse that had followed the exhaustion of the island's resources. A series of catastrophic events in the 19th century, raids by Peruvian slave traders in the 1860s, who carried off a large proportion of the adult population, including most of the island's priestly and intellectual class, followed by an epidemic of smallpox that killed many of those who returned, devastated the population to the point where, by the 1870s, only a handful of the island's original inhabitants survived. Among the casualties of this catastrophe was the knowledge of how to read the Rongo inscriptions. The class of people who had possessed that knowledge, the islanders called them Tangata Rongo, the knowing ones, were gone. When a Catholic missionary named Eugene Aiud arrived on the island in 1864, he noted the existence of the inscribed tablets and reported that almost every house on the island contained one or more of them. He did not think much of them at the time. They seemed to him to be objects of superstitious reverence rather than active use, and he did not collect or preserve them. By the time scholars recognized their importance and began trying to gather examples, most had been destroyed, burned, or hidden. Today, only about 24 objects bearing Rongo inscriptions are known to exist, scattered among museums in Europe, the United States, and Chile. Attempts to decipher the Rongo script have been ongoing since the 1860s, and they have been, to date, largely unsuccessful. Part of the difficulty is the paucity of material. 24 objects is not a large corpus for a decipherment effort. Part of it is the absence of a bilingual text, like the Rosetta Stone, that might provide a key. Part of it is genuine uncertainty about the nature of the system itself, whether it is a full writing system capable of encoding any utterance, or a more restricted system designed to record specific types of content such as astronomical or genealogical information, or a mnemonic system that could only be fully understood by someone who already knew the underlying oral content. Several serious scholars have made genuine progress on partial aspects of the decipherment. Yuri Norizov, the Soviet linguist who cracked the Maya script, turned his attention to Rongo near the end of his life. Jacques Guy and Steve Fisher have both done significant and careful work on the statistical and structural properties of the script. Fisher proposed in the 1990s that certain Rongo passages might record a creation chant of the form X coupled with Y, and from this union came Z, a pattern of cosmogonic narrative common in Polynesian oral tradition. His proposed decipherment was provocative but remains contested. But the most recent and perhaps most significant development in the Rongo story comes from science rather than linguistics. In recent years, researchers have been able to apply radiocarbon dating directly to several of the Rongo tablets, specifically to the wooden objects, since radiocarbon dating requires organic material. The results have been genuinely surprising. The prevailing assumption before the radiocarbon studies was that the Rongo script was a post-contact invention, that Easter Islanders had observed European writing during the early contact period and had been inspired to create their own symbolic system in imitation, without actually understanding how European writing worked. This hypothesis, sometimes called the stimulus diffusion hypothesis, was considered by many scholars to be the most likely explanation, partly because it avoided the uncomfortable implication that the script might represent an independent invention of writing, which would require a serious reconsideration of what we know about the global history of literacy. The new radiocarbon dates complicate this picture significantly. Several of the wooden tablets have been dated to periods that predate or coincide very closely with the earliest European contact with Easter Island. The specific numbers are debated and depend on how the calibration of the radiocarbon dates is interpreted, but some analyses suggest that at least some Rongo objects were made from trees that were felled before any sustained European presence on the island. This does not definitively prove that the script existed before contact. The tablets could have been inscribed on older pieces of wood, but it does make the stimulus diffusion hypothesis harder to maintain with confidence. If the Rongo script was indeed an independent invention, a writing system developed by the people of Rapa Nui without input from or imitation of any external tradition, then it would be one of only a handful of such inventions in all of human history. The consensus among scholars is that writing was independently invented only a very small number of times, in Mesopotamia, in Egypt, in the Indus Valley, in China, and in Mesoamerica. Each of these traditions emerged in complex, socially stratified societies with substantial populations and extensive agricultural economies. Easter Island, by contrast, was a small island with a relatively modest population. The development of writing under such conditions would be extraordinary, and yet the evidence increasingly suggests it may have happened. This is what makes the Rongo tablets so compelling and so important. They are not a hoax, not a misidentification, not a concretion around a modern artifact. They are real, they are ancient, they are inscribed with a system of symbols that is clearly meaningful and clearly systematic, and we cannot read them. The knowledge of how to read them died with the last of the people who possessed it, carried away by epidemic and enslavement before anyone thought to ask them to write it down. The inscriptions themselves survive, silent and eloquent in their silence, in museum drawers and display cases around the world, waiting for the key that may never come, but perhaps it will come. Perhaps it will come from an unexpected direction, from a technology that the makers of the Rongo tablets could not have imagined, applied by people who can read those tablets' surfaces in ways that human eyes alone cannot accomplish. Because the story of the Rongo script intersects, at a surprising angle, with the broader story of how modern science is transforming our understanding of the ancient world, a theme we will return to in the second part of this documentary, when we discuss the remarkable use of artificial intelligence to decode ancient Roman games. For now, however, let us sit for a moment with the weight of what the Rongo tablets represent. They are a message from the past, a deliberate, carefully crafted, systematically arranged message, and we cannot read it. That is not simply an intellectual puzzle. It is a human tragedy. Many someones over many generations worked to encode something they considered worth preserving. Chants, histories, cosmologies, genealogies, astronomical observations, something. They carved their symbols into wood with care and skill, using a system sophisticated enough to represent the complex grammar of a spoken language. And then the thread was cut and the meaning was lost. The Rongo tablets remind us that the past is not simply a record waiting to be read. It is also a graveyard of lost knowledge, and some of what has been lost was extraordinary. We turn now from the small and intimate to the monumentally, almost incomprehensibly large. In Lebanon, in the Bekaa Valley, in the ancient city of Heliopolis, known to the ancient Romans by that name, though the indigenous name of the place is Baalbek, there stands a complex of temples that represents one of the greatest architectural achievements of the ancient world. The temples themselves, dedicated to Jupiter, Bacchus, and Venus, are vast and magnificent structures whose columns and colonnades, even in their partially ruined state, inspire a genuine sense of awe. But it is not the temples that have generated the most persistent mystery. It is what lies beneath them. Beneath the temple of Jupiter at Baalbek there is a platform, not the natural ground, not a simple earthen mound, but an artificial platform constructed from massive blocks of cut limestone, assembled with extraordinary precision into a foundation of almost incomprehensible scale. This platform is sometimes called the Grand Terrace, and it represents one of the most significant engineering challenges in the ancient world. The stones used to construct this platform are enormous. The general facing stones are substantial enough in their own right, 2 to 3 meters in length, roughly dressed and fitted. But interspersed among them, and particularly in the lower courses of the platform, are stones of a scale that strains the imagination. The most famous of these are 3 stones known as the trilithon, which form part of the western supporting wall of the Great Terrace. Each of these 3 stones is approximately 19 meters long, approximately 4 meters high, and approximately 3 meters deep. Each of them weighs, according to various estimates, somewhere between 800 and 1,000 tons. 1,000 tons. That is the weight of 800 to 1,000 modern automobiles. It is the weight of 6 fully fueled commercial jumbo jets. It is a mass so extraordinary that contemplating it at the scale of the ancient world, a world without electric cranes, without diesel engines, without steel cables, without modern materials science, feels genuinely disorienting. How do you move something that weighs 1,000 tons? How do you cut it from the bedrock with the tools available to ancient engineers? How do you lift it? How do you position it with the precision that is evident in the finished structure, where the stones fit together so tightly that in some places it is impossible to slide a piece of paper between them? These questions become even more pressing when you visit the site that is known as the quarry of Baalbek, located about 1.5 kilometers from the main temple complex. In this quarry there are stones that were quarried, that is, cut from the bedrock, but apparently never moved. They remain in situ, their lower surfaces still connected to the parent rock, the cuts that were made to free them visible along their sides and ends. These are the largest known quarried stones on Earth. For many years, the largest known stone at the site was a monolith that scholars call the stone of the pregnant woman, or Hajar el-Hibla in Arabic. This stone is approximately 19 meters long, 4 meters wide, and 4 meters high, and it weighs approximately 800 tons. It is extraordinary by any measure, but in 2014, excavations at the quarry revealed another, previously known but poorly documented stone lying beneath it, even larger. This lower stone has been measured at approximately 19 meters long, 6 meters wide, and about 5 meters high, with a weight estimated at around 1,200 tons. And in 2014 and subsequent years, excavations revealed yet another discovery, evidence of a stone in the same quarry that may weigh as much as 1,650 tons. If that last figure is accurate, it represents the largest single stone ever quarried by human beings anywhere in the recorded history of the world. These facts are not in dispute. The stones are there, they can be measured, their weight can be calculated. The question, the maddening, deeply fascinating question, is how they were intended to be moved, and how the stones that were moved, the trilithon, for example, actually got from the quarry to their current position. The site at Baalbek has Roman-era construction in its upper layers. The temples themselves are clearly Roman, with inscriptions and stylistic features that date them to the 1st and 2nd centuries CE. But the massive platform beneath the Roman construction is another matter. The Roman builders clearly built on top of an existing platform or incorporated existing stones into their construction, but the question of who built the original platform and when has been the subject of considerable debate. Some scholars attribute the entire construction to the Romans, arguing that Roman engineering, while not well documented in the specific case of Baalbek, was capable of accomplishing these feats with the technology available to it. Roman engineers were genuinely extraordinary. They built aqueducts spanning hundreds of kilometers, massive harbor structures, roads that survive to this day, and buildings of remarkable scale and sophistication. The argument is that the Baalbek monoliths, though unprecedented in scale, are not in principle beyond what Roman technology could accomplish with sufficient labor, organization, time, and ingenuity. The counter-argument is that even granting Roman engineering its full credit, the specific problem of the trilithon stones remains unresolved. The largest documented Roman construction cranes could lift, according to various estimates, anywhere from 6 to 30 tons. The trilithon stones weigh between 800 and 1,000 tons each. There is a gap of 2 orders of magnitude between what we know Roman cranes could handle and what would have been required to lift these stones. Filling that gap requires positing either a much more sophisticated Roman lifting technology than any other evidence suggests existed, or a very large-scale system of ramps and levers whose construction would itself have been an enormous engineering undertaking. Experimental archaeology attempts to replicate ancient construction techniques using period-appropriate tools and methods, has been enormously productive in understanding the construction of, for example, Stonehenge or the Egyptian pyramids. In those cases, while the work is staggering, experimental attempts have shown that teams of workers with ramps, sledges, rollers, and sufficient numbers of people can accomplish extraordinary things without modern mechanical advantage. Whether similar approaches could work for the Baalbek trilithon is genuinely uncertain. The mathematics of friction, mechanical advantage, and human force output suggest that even with enormous teams of workers and well-designed lever and fulcrum systems, moving 1,000-ton stones over any significant distance would be extraordinarily difficult. Researchers have proposed various solutions. Massive systems of wooden sledges and rollers over specially prepared paths, gravel and sand displacement methods, systems of levers acting in sequence to inch the stones into position. None of these has been demonstrated experimentally at the Baalbek scale. What makes Baalbek particularly significant in the broader catalog of mysteries is that it cannot be explained away as a misidentification or a fraud. The stones are there. They have been there for a very long time. They were cut from the earth by human hands, and they were at least partially moved and positioned by human hands. The mystery is not whether ancient people built this, they clearly did, but how. And the honest answer is that we do not have a fully satisfying explanation. This places Baalbek in a very different category from the Coso artifact or the Dropa stones. It is not a case of misidentification or fabrication. It is a genuine engineering mystery, an example of ancient capability that exceeds our current ability to fully account for with the evidence available to us. It does not require ancient aliens or lost advanced civilizations to explain, but it does require us to acknowledge that ancient human capabilities, in at least some specific contexts, were more remarkable than our standard historical narratives have tended to assume. And that acknowledgement, that willingness to be genuinely surprised by what ancient people could accomplish, is the thread that connects Baalbek to our next subject, though the two are as different in character as any two things in our catalog. Where Baalbek is massive, raw, overwhelming in its physical scale, the Lycurgus cup is small, delicate, and almost impossibly refined. It sits in the British Museum in London, behind glass, looking at first glance like any number of other remarkable Roman glass artifacts. Beautiful, certainly, but not obviously extraordinary. It is roughly 16 centimeters high, decorated with a scene depicting the mythological story of King Lycurgus of Thrace, who was ensnared in vines by the god Dionysus, and who is shown in a moment of terrible struggle with the divine vegetation that is consuming him. Look at the cup from the front with ordinary daylight falling on it, and it is green, a rich, murky, jade-like green that is beautiful in the way that Roman glass is often beautiful. But now put a light source behind the cup. Now have the light shine through the glass from within rather than reflect off it from without, and the cup transforms. It turns red, a luminous, glowing, wine-dark red that seems to come from inside the glass itself, as though the cup has been lit from within by something alive. This optical phenomenon is called dichroism, the property of appearing to be different colors depending on whether light is reflected from or transmitted through the object. Many minerals exhibit dichroism, many gemstones show it, but glass does not naturally behave this way. Or rather, glass does not naturally behave this way unless something has been done to it. When scientists analyzed a tiny fragment of the Lycurgus cup in the 1990s using electron microscopy, they discovered something that should not have been possible given the object's age. Embedded within the glass, distributed throughout it at a level so fine as to be invisible to the naked eye, were nanoparticles. Gold nanoparticles and silver nanoparticles, each one roughly 50 to 70 nanometers in diameter, 50 to 70 billionths of a meter. These particles were not evenly distributed, but were instead distributed in a specific proportion and at a specific size that produced the dichroic effect. The ratio of gold to silver to manganese in the glass appears to have been carefully controlled to achieve this result. Let that sink in for a moment. A Roman glassmaker or a team of Roman glassmakers, working in the 4th century of the Common Era, approximately 17 centuries before the formal development of nanotechnology as a scientific discipline, managed to distribute metallic nanoparticles of a specific size and ratio throughout a piece of glass in such a way as to produce a precisely controlled and repeatable optical effect. This is not accident. You cannot produce this result by random experimentation without understanding, at some level, what you are doing. The particles are too small to see, and their effect depends on their precise size and distribution. The Romans did not have electron microscopes. They did not have the theoretical framework of quantum mechanics that underlies modern nanotechnology. They did not know what a nanoparticle was in the scientific sense. And yet some craftsperson or group of craftspeople, working in a tradition of glass-making knowledge that was apparently sophisticated enough to achieve results that border on the miraculous, produced this object. Modern researchers working with nanotechnology have been inspired by the Lycurgus cup. Its mechanism of dichroism, the plasmon resonance of metallic nanoparticles at specific sizes, is now one of the active areas of nanotechnology research, with potential applications in medical diagnostics, environmental sensing, and optical computing. A Roman cup from the 4th century CE has become a model for 21st century technology. The Lycurgus cup does not require any revision of the historical timeline. It is what it is, an artifact of the Roman period made by Roman craftspeople. It does not predate its supposed origin. It does not appear in an impossible context. What it does is expand our sense of what was possible within the historical context we already know. It is a demonstration that ancient craftspeople could, in specific domains and specific traditions, achieve results whose mechanisms we are only now beginning to understand, and that is a humbling thing. It is a reminder that the history of human knowledge and skill is not a simple story of linear progress from ignorance to understanding. Some kinds of knowledge were developed and then lost. Some techniques were mastered and then forgotten. Some capabilities that we think of as modern achievements turn out, when we look carefully at the evidence, to have been anticipated by people working thousands of years ago with nothing but their eyes, their hands, and the accumulated wisdom of their craft traditions. From the elegance of the Lycurgus cup, we move to a place where the evidence of ancient precision is written not in glass but in stone, great quantities of stone, shaped and fitted with a care that still commands admiration. We go to Bolivia, we go to Puma Punku. The site of Puma Punku is located near the shores of Lake Titicaca on the Bolivian Altiplano, the high-altitude plateau that sits at roughly 3,800 meters above sea level. It is part of a larger complex that includes the ancient city of Tiwanaku, one of the most significant pre-Columbian civilizations of South America, a polity that reached its height between roughly 500 and 1000 CE, and whose influence extended across a large portion of the Andean region. Puma Punku itself, the name means door of the Puma in Aymara, is characterized by a collection of large stone blocks, many of them carved with extraordinary precision. These blocks are made primarily from two types of stone, red sandstone and gray andesite. The sandstone is relatively local, but the andesite, the gray, harder stone, is thought to have been quarried from a location at least 90 kilometers away and transported to the site, a feat of logistics that at the altitude of the Altiplano would have been enormously demanding. What makes the stonework at Puma Punku particularly striking is the apparent precision of the cutting. Many of the stone blocks feature smooth, flat surfaces, right-angle corners, and geometrically consistent features that suggest the use of precise measurement and sophisticated cutting tools. Some blocks feature what appear to be precisely cut channels and holes, fitted to interlock with other blocks in a manner that echoes modern construction techniques. The tolerances involved, the degree to which fitted surfaces match each other, are remarkably tight. This precision has generated a considerable amount of speculation about the technology involved. Some commentators, particularly those in the ancient alien tradition, have argued that the stonework at Puma Punku could not have been accomplished with the stone and bronze tools available to the Tiwanaku people, that the precision implies power tools of some kind, or at least a level of technological sophistication that exceeds what we attribute to the civilization. This argument has been amplified by the dramatic setting, the remoteness of the site, and the genuinely impressive appearance of the stonework. Archaeologists and engineers who have studied the site offer a more grounded interpretation, but one that is no less impressive for being grounded. The Tiwanaku civilization was sophisticated by any reasonable measure. They maintained an extensive agricultural system based on raised fields that could manage water levels and protect crops from the severe frosts of the Altiplano. They had a system of record-keeping, possibly involving knotted cords similar to the Inca quipu. They conducted extensive trade across the Andean world and maintained a complex social and religious organization capable of directing large-scale labor projects over multiple generations. The precision stonework at Puma Punku, while impressive, is not in principle beyond what can be accomplished with patient labor, careful measurement using simple geometric tools, and experience accumulated over generations. Stone-working traditions around the ancient world achieved extraordinary precision through techniques that, while time-consuming and labor-intensive, did not require powered tools. The key is understanding stone as a material, how it fractures, how it can be ground rather than cut, how surfaces can be achieved through patient abrasion rather than a single precise cut. The specific stone-working techniques used at Puma Punku have been studied through careful experimental archaeology and analysis of the tool marks visible on the stones. The evidence suggests a combination of roughing cuts made with stone tools, followed by ground and polished surfaces. Some of the more precise features may have been accomplished using sand as an abrasive medium with harder rocks as grinding tools, a technique that is extraordinarily labor-intensive but demonstrably capable of producing the kind of flat, regular surfaces visible at the site. None of this diminishes the achievement. A civilization working at 3,800 meters altitude, transporting stones from 90 kilometers away, assembling a monumental complex with precise stonework, using nothing but the materials and techniques available to a society without riding or wheeled transport. That is a remarkable achievement by any measure. The wonder of Puma Punku does not require alien assistance to be genuine and profound. It requires only that we give the Tiwanaku people the credit they deserve. We stay in the realm of underground spaces, of spaces carved from the living rock by human hands, but we move across the globe to southern China, to the banks of the river in the Zhejiang province, to one of the most puzzling sites in the entire world of archaeological anomalies. The Longyou caves, discovered in 1992, when a local villager decided to pump the water out of a pond that had always seemed peculiarly deep and inexhaustible, are a series of enormous artificial caverns carved into the siltstone bedrock. The discovery of the first cave led to the discovery of others, as nearby ponds were pumped out and explored. By the early 2000s, at least 24 caves had been confirmed in a relatively small area. The largest of those excavated measures approximately 10,000 square meters in floor area and stands approximately 30 meters high at its tallest point. The caves are impressive enough in their sheer scale, but what makes them remarkable, what places them in the category of genuine mysteries, is a combination of factors that, taken together, resist easy explanation. The first factor is the uniformity of their construction. The walls, floors, and ceilings of the caves are covered with a regular pattern of parallel chisel marks that are consistent throughout the interior, not just within each individual cave, but consistently across all the caves that have been examined. The marks are set at an angle of approximately 60 degrees to the horizontal and are spaced at regular intervals. This suggests a coordinated, systematic approach to construction, a common standard that was applied across the entire enterprise. The second factor is the scale of the excavation. The total volume of rock removed from these caves is enormous. Conservative estimates suggest that several million cubic meters of stone were removed in the course of creating the cave complex. This is a major undertaking even by modern standards. By the standards of ancient China, working with iron hand tools, it represents an extraordinary investment of labor, an investment that implies a powerful and organized authority directing that labor and a strong motivation for the enterprise. The third factor, and this is the one that generates the most speculation, is the complete absence of any historical record of the cave's existence or construction. Chinese civilization has an exceptionally rich and continuous written record going back thousands of years. The construction of a project of this magnitude, a project that would have required thousands or tens of thousands of workers over an extended period, would ordinarily leave some trace in official records, in local chronicles, in tax records reflecting the requisition of labor, in any of the numerous documentary forms through which ancient Chinese administrators recorded their activities. But no such record has been found. This absence does not prove the caves are mysterious in origin. Records are lost. Local records in particular are vulnerable to the accidents of history, flood, fire, the deliberate destruction of documentation during times of political upheaval. The absence of a record does not mean the record never existed, but it does leave the caves without a historical context that would help us understand who built them, when they were built, and why. Archaeological analysis of the chisel marks and the general construction characteristics has led most experts to assign the caves to the Chinese Qin and Han dynasties, roughly 2,000 to 2,200 years ago. The iron tools and the construction methods are consistent with that period. The caves could potentially be associated with any of several large-scale projects that Chinese rulers of that era were known to undertake: quarrying operations, underground storage facilities, military installations, ceremonial spaces, or administrative complexes. The siltstone rock in which they are carved is relatively soft and workable, which helps explain how such a large volume could have been removed with hand tools in a reasonable period of time. But beyond those general parameters, the specific purpose of the Longyou caves remains genuinely unknown, and that is a rare thing to have a large, complex, clearly purposive human construction in a civilization with excellent historical documentation, and yet to have no idea why it was built. The caves are real, they are impressive, they are ancient, and they are silent about their own meaning. Our final artifact in this first great sweep through the world of anomalies is perhaps the most quietly extraordinary of all, not because it is the most dramatic or the most contested, but because it represents a triumph of ancient knowledge in a domain that we consider firmly our own. It is a pillar of iron standing in a courtyard in New Delhi. It is approximately 7 meters tall and roughly 40 centimeters in diameter. It weighs approximately 6 metric tons. And it has been standing in the open air, exposed to the monsoon rains and the heat of the Indian subcontinent for approximately 1600 years. And it is almost completely free of rust. The Iron Pillar of Delhi, also known as the Qutb Minar Pillar because it now stands in the courtyard of the Qutb Minar complex, was almost certainly manufactured during the Gupta period of Indian history, sometime in the 4th or 5th century CE. An inscription on the pillar refers to a king named Chandra, who most scholars identify as Chandragupta II, who reigned from approximately 375 to 415 CE. The pillar was apparently moved to its current location sometime in the 12th century when the Qutb Minar complex was built. It may originally have stood at a different site, possibly a Hindu temple complex. The iron of which the pillar is made is wrought iron of high purity. But its most remarkable characteristic is its extraordinary resistance to corrosion. Iron in contact with moisture and oxygen rusts. This is basic chemistry, and it occurs at a rate that depends on the composition of the iron, the nature of the surface, and the environmental conditions. A piece of wrought iron standing in an outdoor environment in northern India for 1600 years should be substantially corroded, pitted, weakened, and partially consumed by rust. The Delhi pillar is not. It has a thin surface patina, a dark, slightly mottled coating that is itself a product of the iron's interaction with the environment, but beneath that patina, the iron is essentially intact. It has not rusted in the way that unprotected iron rusts. For many decades, this corrosion resistance was a complete mystery. Metallurgists examined the pillar and found nothing obvious in its composition to explain the phenomenon. The iron was high-purity wrought iron, not stainless steel, not an alloy with known corrosion-resistant properties. The mystery deepened when the history of the pillar's standing was confirmed. 16 centuries is not a marginal case. It is extraordinary. The answer, when it came, was elegant and somewhat unexpected. Researchers analyzing the surface of the iron in the early 21st century discovered that the thin patina on the pillar's surface was not ordinary iron oxide, ordinary rust, but was rather a compound called mesawite, a form of iron hydrogen phosphate hydrate. This compound forms a stable, dense, adherent layer that does not continue to grow into the underlying iron the way ordinary rust does. Instead, it essentially seals the surface, forming a passivation layer that prevents further corrosion. Why did this layer form on the Delhi pillar and not on ordinary iron? The key appears to be the phosphorus content of the iron. The Gupta period iron smelters used a process, operating at relatively low temperatures, using charcoal and specific ores, that resulted in a wrought iron with a higher phosphorus content than modern industrial iron typically contains. This phosphorus, distributed through the iron, interacts with the surface chemistry of the pillar in a way that promotes the formation of mesawite rather than ordinary iron oxide. The specific conditions of production, combined with the subsequent exposure to the alternating wet and dry cycles of the Indian climate, produced the passivation layer that has protected the iron for 16 centuries. The Gupta smelters did not know about phosphorus. They did not know about passivation layers or mesawite or iron hydrogen phosphate hydrate. What they knew was the specific process, the specific ores, the specific temperatures, the specific techniques that produced iron of a certain quality. They had accumulated, through generations of practice and refinement, a knowledge of their craft so deep and precise that it resulted, as an unintended consequence, in a metallurgical achievement that modern science is only now beginning to fully understand. The Delhi Iron Pillar is thus a perfect emblem of the broader theme of this documentary. It is not magic, it is not alien technology, it is not evidence of a lost super-civilization with secrets beyond our comprehension. It is the product of human knowledge, specific, practical, hard-won, sophisticated human knowledge, accumulated over generations and expressed in a piece of craftsmanship that has outlasted its makers by more than 15 centuries. What was lost was not the iron, what was lost was the knowledge of how to make it. The phosphorus-rich low-temperature smelting process that produced the pillar's remarkable iron was eventually superseded by other techniques that were better in most respects, more productive, more consistent, more versatile. But in the specific matter of corrosion resistance, in that one extraordinary quality, the old method was never equaled. The knowledge faded from use, and for 1600 years, the pillar stood as a testament to a craft that nobody knew how to recreate. We have now traveled across a wide and varied landscape of ancient mysteries. We have examined hoaxes and genuine puzzles, fabrications and authentic anomalies, artifacts that dissolved under scrutiny and artifacts that only became more remarkable the closer we looked. We have seen how the desire for extraordinary explanations can lead us to see miracles where there are only concretions. We have seen how the absence of the right questions, asked at the right time, can allow extraordinary knowledge to be lost forever. We have seen how the most remarkable things in the human past are often not the products of alien assistance or advanced lost civilizations, but of patient, skilled, dedicated human beings who knew their materials and their crafts with a depth and intimacy that we have not always given them sufficient credit for. We have visited Iraq, where clay jars may or may not have been ancient batteries. We have examined the ancient quarries of Lebanon, where stones of almost unimaginable mass were cut and moved by methods that still challenge our full understanding. We have held, in our imagination at least, a piece of Roman glass that carries within its molecular structure a command of nanotechnology that embarrasses our sense of ourselves as the first people to discover such things. We have stood before the iron pillar of Delhi and contemplated what it means for knowledge to be encoded in practice rather than theory, to be held in the hands rather than the mind, and to be lost when the hands that hold it are stilled. And we have spent time with the Rongo tablets, those silent, eloquent, maddening inscriptions from the most isolated human community on Earth, and we have sat with the tragedy of a knowledge system destroyed before anyone thought to ask for its key. These are not small things. These are not entertaining footnotes to the real story of human history. They are part of the real story, a part that is too often relegated to the margins, either because it does not fit the conventional narrative or because it has been appropriated by people with less rigorous standards of evidence and thereby made to seem less serious than it is. The honest study of anomalous artifacts and unexplained ancient sites is not a fringe pursuit. It is a genuine and important part of the broader enterprise of understanding where we came from and what human beings are capable of. When we look at the Lycurgus cup and the Delhi iron pillar side by side, we see something genuinely profound, the persistence of human ingenuity across time and the fragility of the knowledge that ingenuity produces. We see how much can be discovered and then lost. We see how thin the thread is that connects one generation's mastery to the next. And perhaps most importantly, we see how much remains to be understood. The world of the ancient past is not a solved puzzle. It is not a closed book. It is a vast, only partially excavated landscape full of objects and places and traces of human activity that we have not yet figured out how to read. Some of what we will eventually discover will confirm what we already believe. Some of it will surprise us in ways we cannot predict. And some of it, if the Rongo tablets are any guide, will remain forever beyond our reach, a reminder that the universe does not owe us all its answers. In the second part of this documentary, we will continue our exploration of the ancient world's most compelling mysteries. We will examine what Ice Age cave art can tell us about the deep history of symbolic thought and recent scientific studies that reveal those ancient marks to be more sophisticated than anyone had imagined. We will explore how artificial intelligence has begun to crack open the secrets of ancient games whose rules were lost 2,000 years ago. And we will return to some of the broader questions that our journey through these artifacts and ancient sites has raised, questions about the nature of knowledge, the meaning of technological sophistication, and what it means to understand a civilization across the vast gulf of time that separates them from us. The past is not done speaking. We are only just beginning to learn how to listen. The stones wait, the tablets wait, the pillar stands in its courtyard in the heat and the monsoon rain, refusing to rust. And somewhere in a museum drawer or a scholar's archive or beneath the soil of a hillside not yet excavated, the next mystery waits to be found. Stay with us, we are only halfway through. We left the first part of this documentary standing before an iron pillar that refuses to rust, a monument to the deep knowledge of ancient craftspeople and to the fragility of the traditions that carried that knowledge forward through time. We left it contemplating the silence of the Rongo tablets, the weight of the Baalbek monoliths, the impossible elegance of a Roman cup that understood nanotechnology before the word existed. We left it with a question hanging in the air like smoke, not the dramatic question that the ancient alien theorists ask, not the breathless "could this have been built by visitors from the stars?" but something quieter and more unsettling and ultimately more interesting. The question is this: how deep does human knowledge go? Not how sophisticated were our machines, not how advanced was our technology in the narrow industrial sense. But how far back does the distinctly human capacity for complex thought, for symbolic reasoning, for the encoding of meaning in physical marks, for the transmission of hard-won knowledge across generations, how far back does all of that actually extend? Because the answer to that question shapes everything else. It shapes how we understand the artifacts we discussed in the first part of this documentary. It shapes how we interpret the anomalies that still resist easy explanation. And it shapes, at the deepest level, our sense of what human beings are and have always been. The conventional story of human cognitive development has, until relatively recently, drawn a fairly sharp line between the very ancient past, the hundreds of thousands of years of our species' existence before the relatively sudden flowering of what archaeologists call behavioral modernity, and the period that begins roughly 50,000 years ago, when the archaeological record begins to fill up with evidence of symbolic behavior, art, ornamentation, complex tools, and the other markers that we associate with minds like our own. Before that line, the story goes, our ancestors were anatomically modern but cognitively simpler, capable of survival and even remarkable physical accomplishments, but not yet possessed of the full suite of cognitive tools that make symbolic thought, language in its full complexity, and cultural transmission possible. That story has always had its critics. And in recent years, the evidence against the sharpness of that line has grown substantially. Cave paintings older than expected, shell beads used as personal ornamentation dating back 100,000 years or more, ochre and other pigments showing signs of deliberate use at sites in Africa that date to 200,000 years ago or beyond. The line has been blurring, pushed back and back and back, and with each revision our sense of what was happening in the minds of our very ancient ancestors has had to shift accordingly. But it is in the more recent past, the period of the last ice age, roughly 20 to 30,000 years ago, that the most remarkable new evidence has emerged. Evidence that not only confirms the existence of sophisticated symbolic thought in that period, but goes considerably further. Evidence that suggests that the people of the Ice Age were not simply making art in the intuitive, unstructured sense, expressing themselves through images, and marks the way a child might paint with instinct and emotion. The evidence suggests that they were doing something more organized, more systematic, something that in retrospect looks remarkably like the early stages of the very thing that we found being accomplished in full maturity on the wooden tablets of Easter Island. They were encoding information. To understand what that means and why it matters, we need to back up slightly and talk about what symbolic encoding actually is, because the term can mean many things and precision is important here. At the most basic level, symbolic encoding is any process by which a physical mark or object is used to represent something other than itself. A sound, a concept, a number, a relationship, a sequence of events. The alphabet you are reading is a system of symbolic encoding. So is a musical score. So is the knotted chord record-keeping system of the Inca. So arguably are the geometric patterns on a piece of Paleolithic cave art, if those patterns were intended to represent something beyond their own visual appearance. The question of whether Paleolithic cave art contains systematic symbolic encoding has been debated for decades. The paintings themselves, the magnificent bison and horses and mammoths and deer of Lascaux, of Altamira, of Chauvet, are clearly representational, clearly skilled, clearly the products of minds capable of complex visual thinking. But representational art and symbolic encoding are not quite the same thing. A beautiful painting of a horse represents a horse, but unless there is a system, a code, a set of conventions agreed upon and transmitted, it does not encode information in the way that writing or mathematics encodes it. For a long time, the geometric marks that accompany the figurative paintings in many cave sites, the dots, the lines, the chevrons, the tectiforms, the abstract symbols that appear alongside and sometimes integrated with the animal figures, were treated as decoration, as the products of artistic impulse without specific informational content. But a series of studies, building on each other over the past decade, have begun to suggest that this interpretation is wrong. Not just somewhat wrong, but significantly and interestingly wrong. The most comprehensive of these studies was conducted by a team of researchers including Dr. Ben Bacon, a furniture conservator and amateur researcher, and several professional academics, whose work was published in the Cambridge Archaeological Journal. Their study examined a large number of Paleolithic cave sites across Europe, focusing specifically on the marks that appear in association with depictions of animals. They were looking for patterns, for evidence of systematic, non-random arrangement that would suggest the marks were being used to record something specific. What they found was striking. The marks associated with animal depictions, particularly sequences of dots, lines, and other non-figurative symbols, appeared to follow a consistent pattern when examined across multiple sites. Specifically, the marks seemed to encode a lunar calendar of sorts, a system for recording the timing of key events in the annual cycle of the animals depicted. The numbers of marks, the types of marks, and their arrangement in sequence appeared to correspond, with a consistency that exceeded what chance would predict, to a system for tracking breeding seasons, migrations, and other key points in the annual behavioral cycles of prey animals. In other words, the Ice Age cave painters were not simply decorating the spaces around their animal images. They were annotating them. They were adding a layer of information, temporal, ecological, practical information about when those animals could be found in particular behavioral states that would be relevant to hunters. They were, in a very real sense, writing notes. This interpretation is not universally accepted. Archaeology rarely produces the kind of unambiguous evidence that makes controversy easy to resolve, and the reading of prehistoric symbolic systems is an enterprise that requires considerable inference at every step. But the statistical evidence for non-random patterning in the marks is robust, and the correspondence between the proposed encoding system and the actual behavioral biology of the animals depicted is too consistent to dismiss as coincidence. What this means, if the interpretation is even partially correct, is that the capacity for symbolic data recording, for using physical marks in a systematic, agreed-upon way to convey specific information across time and space, is considerably older than formal writing systems. The earliest formal writing systems in Mesopotamia, in Egypt, in the Indus Valley, in China, date to roughly 5,000 years ago. The Ice Age cave markings being studied are 15,000 to 30,000 years old. If those markings constitute a form of systematic information encoding, then the history of writing as a cognitive practice, as a way of using the material world to store and transmit knowledge, extends back not 5,000 years, but 30,000. This does not mean that Ice Age cave painters had writing in the full sense that we mean when we talk about the Sumerian cuneiform tablets or the Egyptian hieroglyphic inscriptions. What it means is that the cognitive building blocks of writing, the capacity for symbolic encoding, for agreed-upon systems of marks, for the transmission of encoded information within a community, were already present and already being exercised 30,000 years ago. The specific technologies of writing, the clay tablets, the reed stylus, the papyrus roll, the brush and ink, came later, much later, but the underlying cognitive machinery was already running. This finding connects directly to one of the themes we explored in the first part of this documentary, the question of what the Rongo tablets represent. If symbolic encoding is 30,000 years old as a cognitive practice, then the apparent independent invention of a writing system by the people of Easter Island, while still remarkable, is perhaps less inexplicable. It is not the invention of an entirely new cognitive capacity. It is the application of a very ancient capacity to a new medium, a new social context, a new set of communicative needs. The capacity was always there. What varies across human cultures and across time is not the fundamental ability to create and use symbolic systems, but the specific forms those systems take and the specific purposes they serve. This is a profound reframing. It does not diminish the achievement of the Rongo people, any more than recognizing that humans have always been capable of language diminishes the achievement of any particular literary tradition. But it places that achievement within a longer and richer context, a context in which the making of meaningful marks is not an invention but an inheritance, not a new capacity but the exercise of something ancient and deep. Let us stay for a moment with the caves, not with the paintings this time, but with something more specific, with the question of what it feels like to be inside one of those spaces, in the darkness, by firelight, with the images emerging from the rock as though they are alive within it. The people who made these paintings did not simply walk into a bright, well-lit gallery and apply pigment to an available wall. The deep chambers of caves like Chauvet and Lascaux are remote from the surface, accessible only through passages that require crawling, climbing, and navigation in the dark. The painters carried their light sources with them, small stone lamps burning animal fat or torches of twisted plant fiber. By the light of those lamps and torches, flickering, organic, throwing moving shadows, the images they painted would have seemed to breathe. The rounded surfaces of the cave walls, worked to the painter's advantage, would have given the animal figures a three-dimensional quality, a sense of physical presence that flat viewing cannot replicate, and now add the marks. The sequences of dots and lines, perhaps counting the lunar cycles, perhaps tracking the seasons, perhaps recording the timing of migrations. Add the knowledge that someone, generations before you, made those marks in this specific place for a specific reason, that they left information here for you, encoded in a system you were taught to read, preserved in the darkness and the cold. Imagine that act of reading by firelight, decoding a message left by an ancestor in the depths of a mountain. What you have in that imagined moment is not the primitive superstition of a simple people. What you have is a library. A dark, underground, flickering library, its shelves made of stone, its texts inscribed in red ochre and charcoal and manganese dioxide, its catalog system based on the movements of the moon. It is a different kind of library from the ones we know, different medium, different retrieval system, different social context for the act of reading. But in its essential function, the preservation of information across time, the transmission of hard-won knowledge from those who discovered it to those who will need it, it is recognizably the same thing. When we understand the Ice Age caves in this light, the line between the prehistoric and the historical, between the time before writing and the time after, becomes considerably less sharp. Not because there was no change, no development, no genuine innovation in the invention of formal writing systems. There clearly was, but because the cognitive foundation on which those innovations were built was already in place, already functioning, already producing results of practical value to the communities that maintained it. The history of human knowledge is longer and less interrupted than we have sometimes assumed. From the distant past of the Ice Age, we make a long leap forward in time, but not away from the question of how we recover lost knowledge. Because one of the most exciting developments in the study of the ancient world in recent years has been the application of modern computational technology, specifically artificial intelligence, to the problem of understanding things that time and history have rendered opaque. And nowhere has this been more entertainingly demonstrated than in the attempt to understand what ancient people did with their leisure time. Games are among the most universal of human activities. Every human culture we know of has played games, games of chance, games of strategy, games of physical skill, games that combine all three. Games serve functions beyond simple entertainment. They teach strategic thinking, they model social relationships, they provide a controlled arena for competition that might otherwise be destructive, they reinforce cultural values, and they provide a shared framework of rules and expectations within which a community can interact. The rules of a culture's games, in some sense, reflect the rules of its society. The ancient Romans were enthusiastic and prolific game players. We know this from literary sources, from artistic representations, and from the physical evidence of gaming equipment, dice, game pieces, and game boards that survives in considerable quantity from the Roman period. Some Roman games are well understood. We know the rules of some forms of tabula, a backgammon-like game played on a board with counters and dice. We know the basic principles of latrunculi, a strategic game played on a grid with two types of pieces, somewhat analogous to chess. We know about the various forms of dice games and knucklebone games that were played by Romans of all social classes. But there are other Roman games, represented by boards found inscribed into stone in public spaces, in the floors of basilicas, in the pavement of forums, in the thresholds of houses, whose rules are entirely unknown. These boards were clearly used. They show the wear patterns that come from repeated use over many years. They were clearly important enough to carve into permanent surfaces rather than marking a temporary playing space. But the specific rules that govern play on them, the strategies involved, the object of the game, all of that was lost when the game itself fell out of use, along with the civilization that played it, until perhaps very recently. Researchers at several European universities, working in collaboration with specialists in machine learning and computer vision, have applied artificial intelligence analysis to the examination of Roman game boards in a way that has yielded promising results. The specific approach involves training machine learning systems to analyze the microscopic wear patterns on the surfaces of stone game boards, patterns that are invisible or nearly invisible to the naked eye, but that can be detected through high-resolution scanning and photogrammetry. These wear patterns are the accumulated record of thousands of individual plays, the places where game pieces were placed most often, the paths along which pieces were moved, the areas of the board that saw the most interaction. The logic of this approach is elegant. If game pieces were placed on certain positions more often than others, those positions will show greater wear. If pieces were moved along certain paths, those paths will show characteristic patterns of surface abrasion. If pieces were picked up and placed down repeatedly in specific ways, the microscopic texture of the stone at those locations will differ from areas that saw less activity. All of this information is encoded in the stone, but it is encoded at a scale and in a form that human visual inspection cannot reliably detect. The artificial intelligence systems, trained on the wear patterns of game boards whose rules are known, learn to recognize the characteristic signatures of different types of play. They learn, in effect, to read the stone, not in the literary sense, but in the physical sense. They read the record of use that has been written into the surface of the board by generations of players who never thought they were leaving a record, who were simply playing. The results of applying this analysis to unknown Roman game boards have been genuinely interesting. In several cases, the AI analysis has identified patterns of wear that are consistent with specific types of game mechanics. patterns suggesting that pieces were moved in particular sequences, that certain positions were contested more than others, that the board was divided into functional zones that saw qualitatively different types of play. From these patterns, researchers have been able to propose tentative rule sets, hypothetical reconstructions of how the games might have been played, that are consistent with the physical evidence and with what we know independently about Roman gaming culture. These reconstructions are tentative. They are hypotheses, not certainties. The process of going from where patterns to game rules involves inference at multiple steps, and the AI systems, while powerful, are not infallible interpreters. But the approach represents something genuinely new in the study of the ancient world, a way of extracting information from objects that carry their record of use in their physical substance rather than in any form of explicit inscription. It is archaeology at the microscopic scale, made possible by computational tools that would have been unimaginable a generation ago, and it connects to a broader theme that runs through this entire documentary. The information is there. It has always been there, waiting to be read. What changes across time is our capacity to read it. The Romans who played their games on those stone boards left a record, not intentionally, not in the sense of writing down the rules for posterity, but physically, inevitably, through the act of play itself. The stone remembered in its own way long after the players were gone. And now, 16 or 18 centuries later, we are developing the tools to listen to what the stone is saying. This is what the best modern archaeology feels like, not the dramatic discovery of a treasure-filled tomb, though those moments are genuinely exciting, but the slow, patient, methodical extraction of information from the silent physical record of the past. It is a conversation conducted across millennia, in a language made of where patterns and chemical gradients and radiocarbon ratios and the statistical distribution of marks on a cave wall. It requires patience and tools and imagination. And it is producing, year by year, a picture of the human past that is richer and stranger and more interesting than any previous generation has been able to see. The application of artificial intelligence to ancient game boards is a specific example of a much broader revolution that is currently transforming the field of archaeology and the study of the ancient world. It is worth pausing to survey that revolution, because understanding it is essential to understanding where the field of ancient mysteries is headed, which anomalies are likely to be resolved in the coming decades, and which are likely to remain genuinely open. The revolution is multifaceted. It involves not just AI and machine learning, but also advances in imaging technology, in genetic analysis, in isotopic chemistry, in satellite and aerial survey, and in materials science. Each of these tools is, in effect, a new way of asking questions of physical objects and physical landscapes, a new way of making things speak that have previously been silent. DNA analysis has been perhaps the most publicly dramatic of these advances. The ability to extract and sequence ancient DNA from skeletal remains has completely transformed our understanding of human population history, of who lived where, when, and in what relationship to other populations. Migrations that were invisible in the archaeological record have been revealed by genetic studies. Population replacements and admixtures that left no obvious trace in the material culture have been detected in the genomes of ancient individuals. The deep history of humanity is being rewritten, year by year, by the information preserved in ancient bones and teeth. For the study of anomalous artifacts and mysterious ancient sites, genetic analysis offers specific and valuable tools. In cases where skeletal remains are associated with unusual artifacts, like the small-statured remains allegedly found with the Dropa stones, or the unusual graves associated with various anomaly claims, DNA analysis can provide information about the biological identity of the individuals involved, their relationships to other populations, their health and diet, and their geographic origins. This kind of evidence can either support or definitively refute claims about anomalous populations or unusual individuals. Isotopic analysis, the study of the ratios of different isotopes of elements like strontium, oxygen, and carbon in ancient materials, provides a different kind of window into the past. The isotopic signature of a person's teeth, for example, reflects the isotopic composition of the water and food they consumed during childhood. Since different geographic regions have characteristic isotopic compositions, analyzing the isotopic signature of ancient teeth can tell us where a person spent their early years. This technique has been used to identify ancient migrants, to trace the movement of craftspeople between communities, and to understand the dynamics of ancient trade networks. For the study of objects like the aluminum wedge of Aiud or the Baghdad battery, Isotopic and elemental analysis of the materials can provide crucial information about their origins and manufacturing processes. Where did the metal come from? What temperature was used in its production? What impurities are present? And what do they suggest about the ore source and smelting technique? These questions can sometimes be answered with great precision using modern analytical tools, and the answers can either confirm or challenge claimed interpretations of the object's origins and ages. Remote sensing, the use of satellite imagery, aerial photography, LiDAR scanning, and ground-penetrating radar to survey landscapes without excavation, has been transforming our understanding of ancient sites on a large scale. LiDAR in particular has been revolutionary. It uses laser pulses to create detailed three-dimensional maps of landscape surfaces, and it can penetrate forest canopy to reveal the features of the ground beneath. LiDAR surveys of jungle regions in Central America have revealed extensive ancient Maya urban complexes that were invisible to ground-level survey, and that have fundamentally changed our understanding of the scale and complexity of Maya civilization. Similar surveys are being conducted at sites across the world, and the results are consistently expanding the known extent of ancient human activity. For sites like Puma, Punku, and Baalbek, where the visible remains represent only a fraction of what may lie beneath the surface, remote sensing tools offer the possibility of understanding the full extent and organization of the ancient complexes in ways that are not possible through excavation alone. Ground-penetrating radar surveys at Baalbek have already revealed the presence of previously unknown underground structures in the vicinity of the main temple complex, structures whose nature and function are not yet understood, but whose existence suggests that what we see on the surface is only part of a larger and more complex ancient landscape. And then there is the ongoing development of computational analysis tools, not just AI for game boardware patterns, but machine learning systems applied to the corpus of undeciphered ancient scripts, computational linguistic analysis of patterns in ancient texts, and statistical approaches to the distribution and frequency of symbols in inscription systems. These tools are being applied to the Indus Valley script, to Linear A of the Minoan civilization, and to the Rongo tablets of Easter Island, to all of the major undeciphered writing systems that remain beyond our current ability to read. The decipherment of an ancient script is one of the most intellectually demanding achievements in all of scholarship. It requires a combination of linguistic expertise, cryptanalytic thinking, knowledge of the relevant ancient culture, and a particular kind of creative intuition that is difficult to describe but instantly recognizable in those who possess it. The major decipherments of the 20th century, of Linear B by Michael Ventris, of the Maya script by a generation of scholars including Yuri Norizov and David Stewart, were achievements of individual brilliance working within a framework of accumulated scholarship. Machine learning cannot replace that kind of insight. But it can support it by identifying patterns in large datasets that would take human researchers years to process manually, by flagging structural regularities in symbol distributions that might suggest specific grammatical or phonetic properties, by generating hypotheses that human experts can then evaluate and test. The combination of computational power and human interpretive skill may prove to be, in the coming decades, the key to unlocking writing systems that have resisted centuries of human effort. If the Rongo tablets are ever deciphered, and we cannot know whether they will be, because the corpus may simply be too small and too isolated to yield to any analytical approach, it will almost certainly involve this kind of human-machine collaboration. And if that decipherment comes, it will be one of the great moments in the history of human scholarship. We will hear, for the first time in over a century, voices that were silenced by epidemic and enslavement. We will learn what the Tangata Rongo considered worth preserving, what knowledge, what histories, what chants and cosmologies they encoded into those careful, elegant symbols and carried with them across the most remote ocean on Earth. Let us step back now from the specific artifacts and the specific technologies and ask the larger question that all of this evidence is pushing us toward. Because there is a pattern in everything we have examined, in the Ice Age cave art with its encoded lunar calendar, in the Rongo tablets with their independent invention of writing, in the Lycurgus cup with its nanotechnology, in the Delhi iron pillar with its superior metallurgy, in the Baalbek monoliths with their engineering challenges, in the Longyou caves with their mysterious purpose. There is a pattern, and it is worth articulating clearly. The pattern is this: ancient human beings were capable of significantly more than the conventional narrative of linear progress from primitive to sophisticated has generally allowed. Not more in the sense that they had access to modern technology or to extraterrestrial assistance or to the products of a lost super-civilization. More in the sense that the specific kinds of knowledge, skill, and organizational capacity that they developed in specific domains for specific purposes could reach extraordinary heights that we have tended to underestimate because we have been measuring them against our own benchmarks rather than against the benchmarks of their own circumstances. This matters because of the way it shapes our relationship to the past. If we see the past as simply primitive, as a less developed version of the present, moving steadily upward through time toward us, then the anomalous artifacts and the impossible engineering feats and the sophisticated craft traditions are simply puzzles to be explained. Interesting puzzles, perhaps, but fundamentally curiosities. They do not challenge the underlying narrative, they are just exceptions to be accounted for. But if we see the past as a landscape of variable achievement, of peaks and valleys, of knowledge accumulated and lost and accumulated again, of specific domains of mastery that were sometimes extraordinarily deep and sometimes lost without trace, then the anomalous artifacts become something more significant. They become evidence for a different way of understanding human history. Not a revolutionary, civilization-overturning rewrite, but a genuine enrichment and complication of the story. A recognition that the path from then to now was not a simple upward slope, but a complex terrain, with crevasses and plateaus and surprising elevations in unexpected places. This is the picture that the careful study of anomalous artifacts supports. Not ancient astronauts, not Atlantis, not conspiracy theories about suppressed advanced civilizations. Just a richer, more complicated, more honest account of what human beings have done with the extraordinary cognitive gifts they have been carrying since at least the time of the Ice Age cave painters. Perhaps considerably longer. There is one more dimension of this question that deserves careful attention, and it is the dimension that connects the most ancient evidence, the Ice Age cave markings, to the most recent scientific developments. It is the question of what we mean when we talk about intelligence, and what the evidence of the ancient world is telling us about the relationship between intelligence, knowledge, and technology. In modern discourse, we tend to conflate these three things. We assume that intelligence produces knowledge, that knowledge produces technology, and that the level of technology a civilization possesses is roughly proportional to its intelligence and the depth of its knowledge. This is why the ancient alien hypothesis has such persistent appeal, because when we see evidence of ancient technological achievement that exceeds our expectations, our first instinct is to look for an external source of intelligence and knowledge that could explain it. If people at that level of technology could not have done this, then someone or something with a higher level of technology must have done it for them. But the conflation of intelligence, knowledge, and technology is misleading. Intelligence, the fundamental cognitive capacity to perceive patterns, form abstractions, solve problems, and communicate complex information, is not something that varies significantly across human populations or across human history. The cognitive machinery of a modern neuroscientist is not fundamentally different from the cognitive machinery of a Paleolithic cave painter. What differs is the accumulated body of knowledge each has access to, and the technological tools available to convert knowledge into physical results. Knowledge, unlike intelligence, is not innate, it is accumulated and transmitted culturally. It builds over time. Each generation in each domain adds a small increment to what was inherited from the previous generation. Over thousands of years, these small increments can add up to remarkable depth in specific areas. A tradition of glassmaking practiced and refined over generations can, without any dramatic leap of genius, accumulate a level of craft knowledge deep enough to produce the Lycurgus cup. A tradition of iron smelting practiced and refined over generations can, without anyone understanding the chemistry involved, discover and preserve the specific process conditions that produce corrosion-resistant iron. The depth is in the tradition, in the accumulated experience, not in any special intelligence of the individual practitioners. And technology, the physical tools and processes that convert knowledge into material results, is not a simple linear progression either. Different technologies are better suited to different purposes. A Stone Age napper who could produce a perfect biface, a precisely worked stone tool, in a few minutes was exercising a level of perceptual motor skill that most modern people cannot replicate despite years of practice. The technology of stone tool making reached extraordinary sophistication over hundreds of thousands of years of development. When that technology was superseded by metal working, the specific skills of stone knapping were not taken to a higher level, they were abandoned. The knowledge was lost. In that specific domain, the transition from stone to metal was not an upgrade but a replacement, and the replacement involved losses as well as gains. This pattern of deep, accumulated knowledge in specific domains being lost when the social or material conditions that supported it changed is visible throughout human history. The Roman concrete that has survived for 2,000 years submerged in seawater, still stronger than modern Portland cement in some key respects, represents a knowledge of specific volcanic aggregate and seawater interaction that was lost in the medieval period and only recently reconstructed by materials scientists studying ancient harbor structures. The Byzantine Greek fire, the incendiary weapon that was the terror of medieval naval warfare, used a recipe that was kept so secret and so restricted that when Byzantine civilization ended, the recipe ended with it. Medieval Venetian glassmakers maintained trade secrets of such severity that craftspeople who attempted to leave the island of Murano, taking their knowledge with them, could be legally hunted down and killed. Knowledge, in other words, is precarious. It exists in people and in the social structures that support those people. When the people are gone by plague, by war, by the disruption of trade networks, by the collapse of the social structures that organized and transmitted their knowledge, the knowledge goes with them. And sometimes all that remains is the product, the iron pillar standing in its courtyard, the glass cup sitting in its museum case, the massive stone platform waiting silently for someone to explain how it was built. This understanding of knowledge as precarious, as domain-specific, as the product of accumulated tradition rather than individual genius, has important implications for how we interpret the anomalous artifacts we have examined in this documentary. It suggests that we should be neither surprised nor disbelieving when we encounter evidence of ancient achievement in specific domains that exceeds our general expectations. It suggests that the history of technology is not a story of uniform advance but of uneven development, of extraordinary depth in some areas coexisting with much more limited capability in others, of specific mastery that sometimes exceeds what later periods achieved in the same domain. The Delhi iron pillar fits this picture perfectly. The Gupta metallurgists who produced it were not generally more advanced than later iron workers. They were specifically more skilled in one particular aspect of iron production, the one that happened, as a byproduct, to produce corrosion-resistant iron. That specific skill was eventually superseded by other approaches, not because those approaches were better in every respect, but because they were better in enough respects to displace the older tradition. The specific corrosion resistance property was not recognized as a distinct achievement. It was just a characteristic of the iron that came from a particular process, and so when the process changed, the property was lost along with it. The Lycurgus cup fits the same pattern. Roman glassmakers had developed, over centuries of practice, a craft tradition that included the incorporation of metallic particles into glass for aesthetic purposes, for achieving specific colors and optical effects that customers valued. The specific combination of particle sizes and compositions that produces dichroism was probably discovered empirically, through systematic experimentation and selection of results, without any theoretical understanding of why certain approaches worked and others did not. The tradition was maintained because the results were valued and the process was teachable, even without understanding. When Roman civilization collapsed and the specific workshop traditions that maintained the knowledge were disrupted, the technique was lost. The cup survived, the knowledge of how to make another one did not, and Baalbek fits the picture too, though in a different way. The engineering of the Baalbek platform, if it was achieved by Roman or pre-Roman engineers using conventional ancient technology, represents the extreme upper limit of what that technology could accomplish. It represents a mobilization of the specific knowledge of stone working, of lever mechanics, of large-scale labor organization, that probably took generations to develop and required specific social and political conditions to maintain. When those conditions changed, when the Roman imperial machinery that could organize and sustain such projects collapsed, the specific expertise required to move 1,000-ton stones was not handed on, because the conditions that would have called for its exercise no longer existed. The knowledge was not written down. It was held in the experience of the engineers and laborers who had done it, and when they were gone, it was gone. This does not resolve the specific engineering mystery of how the Baalbek trilithon was moved. It does not give us the blueprint for the specific mechanism that achieved it. But it places that mystery within a framework that makes it comprehensible, not as evidence of supernatural or extraterrestrial assistance, but as evidence of human engineering knowledge operating at its extreme historical limit, accumulated and then lost, leaving its products behind for future generations to puzzle over. We have been talking about loss, about knowledge lost, traditions interrupted, voices silenced. But the story of the ancient world is not only a story of loss. It's also a story of persistence, of things that survived when everything around them collapsed, of knowledge that found unexpected pathways through the catastrophes of history, of physical objects that outlasted the civilizations that made them to carry their evidence forward into a future their makers could not have imagined. The Rongo tablets survived. Not many of them, the great majority, were burned or hidden or simply deteriorated in the tropical climate before anyone thought to preserve them. But enough survived to reach the museums and collections where they now sit, waiting for the key that may still come. The tablets survived because a few Catholic missionaries recognized their cultural significance even when they did not understand their content. The tablets survived because of the particular durability of the wood used to make some of them. The tablets survived because, across the catastrophe of disease and enslavement that destroyed the culture that made them, enough people and enough objects persisted to give future scholars something to work with. The cave paintings of Chauvet survived 30,000 years in the darkness of a cave sealed by a rockfall. They survived long enough to be discovered in 1994 by cavers who recognized immediately that they were looking at something extraordinary. They survived in such good condition that the pigments still hold their color, the outlines still convey the remarkable observational skill of the artists who made them, and the associated marks, the dots and lines and non-figurative symbols, are still clear enough to be analyzed by researchers looking for patterns. The Lycurgus cup survived the collapse of the Roman Empire, survived the medieval period, survived the Renaissance and the Enlightenment and the Industrial Revolution, until it ended up in the hands of the Rothschild family in the 19th century and eventually in the British Museum in the 20th, where modern electron microscopy could finally reveal the secret of how it works. Physical objects are in a profound sense the most reliable transmitters of ancient knowledge, more reliable than any social institution, more durable than any human memory, more resistant to the accidents of history than any deliberately constructed archive. They do not choose what to remember, they do not edit or revise, they simply persist, carrying their information in their physical substance, waiting for the questions that will reveal what they know. This is why the study of ancient artifacts, even anomalous ones, even puzzling ones, even ones that have been surrounded by unreliable claims and wishful thinking, is so important. Not because every anomalous artifact is evidence of something extraordinary. Many of them are not. Many of them are ordinary objects misidentified, as we saw with the Coso artifact and the London hammer. But because the process of careful examination, of bringing the full toolkit of modern science to bear on these objects, of asking not, what do I want this to be, but what does the evidence actually show, is the process by which the genuine mysteries are separated from the false ones, and the genuine mysteries, as we have seen, are remarkable enough on their own terms. There is a temptation in a documentary like this one to end with a grand synthesis, with a sweeping statement about what all of this evidence means, about what picture of the ancient world it adds up to, about the definitive conclusion that follows from everything we have examined. But the honest conclusion, the one that the evidence actually supports, is more modest and more interesting than any grand synthesis. The honest conclusion is that we are still learning. That the picture of the ancient world we carry in our heads, formed by textbooks and documentaries and the accumulated scholarship of generations, is a good picture, a carefully constructed picture, a picture that represents our best current understanding. But it is not a complete picture. It is not a final picture. It is a picture that is being revised, enriched, and in some places fundamentally reconsidered by new evidence and new analytical tools, and the revisions are not trivial. The evidence from Ice Age cave art suggests that symbolic encoding, the cognitive precursor to writing, is tens of thousands of years older than we thought. The radiocarbon dates from Rongo tablets suggest that independent writing systems may have emerged in places and under conditions that do not fit our standard models of how writing develops. The Lycurgus cup tells us that ancient craft traditions could achieve results in specific domains that anticipate modern science by millennia. The Delhi iron pillar tells us that ancient metallurgical knowledge could produce physical effects that modern industrial processes have not reliably replicated. The Baalbek monoliths tell us that ancient engineering operated at scales that still challenge our full understanding. The Longyou caves tell us that ancient societies could undertake enormous projects and leave almost no documentary trace. None of this requires us to posit ancient aliens. None of it requires a lost super-civilization. None of it requires the suppression of a secret history. What it requires is a willingness to look carefully at the evidence, to follow it wherever it leads, and to hold our conclusions provisionally, firmly enough to act on the best available evidence, but loosely enough to revise when new evidence demands it. This is, in the end, a description of the scientific method, of the historical method, of the attitude that any honest investigator brings to the unknown. It is not the most dramatic attitude. It does not produce the rush of certainty that comes with a definitive proclamation, the thrill of believing you have cracked open a secret that the mainstream has hidden or missed, but it produces something more valuable than that thrill. It produces actual understanding that grows over time, that accumulates and deepens, that sometimes produces genuine surprises, and that is always, in its honest incompleteness, more interesting than any premature certainty. Let us make one more visit before we close to the places and objects that have been the companions of this long journey through the ancient world. Let us visit them not as puzzles to be solved, but as they actually are, as the physical residue of human lives, fully lived in circumstances we can barely imagine. Imagine the person who helped quarry one of the Baalbek stones, not the engineer who designed the system, not the official who ordered the construction, but an ordinary laborer, someone who spent days or weeks working at the face of the limestone, driving wedges into the rock, breaking away fragments, hauling debris. What did that person think about while they worked? What did they eat, and who did they eat with? What did they believe about why this enormous thing was being built and what its completion would mean? We will never know. They left no record. Their life dissolved into history without a trace, and the only thing that survived, the only thing that carries any evidence that they existed, is the cut stone that their labor helped to free from the earth. Imagine the person on Easter Island who carved a sequence of symbols into a piece of wood, carefully, with a tool of obsidian or shark's tooth, working by whatever light was available. Were they working from memory, reciting the text silently as they carved? Were they copying from an older piece, already worn, already at risk of being lost? Were they training an apprentice, explaining the system as they worked? What did they feel about the significance of what they were doing? Were they aware that they were practicing something rare, something that most of the world did not have, or was writing simply a normal part of the intellectual life of their community? We will never know that either. The person is gone. The tablets remain. Imagine the Roman glassmaker or the team of Roman glassmakers who worked out, through years of experimentation, the specific recipe that produced the dichroic effect of the Lycurgus cup. They must have noticed at some point that glass made with certain materials in certain proportions did something unusual, changed color in the light. They must have tried to reproduce it, experimenting with different ratios and different conditions, gradually converging on the combination that produced the most dramatic effect. They were doing, in their workshop with their tools and their materials and their practiced eyes, something that we would now call experimental science. What did they call it? Did they keep records, or was the knowledge maintained entirely in the hands and the memory? When the workshop was eventually abandoned, moved, destroyed, its craftspeople dispersed, how quickly did the knowledge begin to fade? These are not answerable questions. They are rather the questions that the objects themselves generate when we look at them honestly, when we stop seeing them as puzzles and start seeing them as the products of real human lives. When we allow the wonder of their existence to be the wonder of human existence, rather than the wonder of the extraterrestrial or the supernatural. The ancient world was not a simple place. It was not populated by simple people. From the earliest evidence of our species' cognitive activity, the ochre-stained shells, the geometric engravings, the first pigmented marks on stone, through the Ice Age cave paintings with their encoded astronomical data, through the invention and reinvention of writing systems across 5 continents, through the extraordinary craft traditions that produced nanotechnology in Roman glass and corrosion-resistant iron in Gupta-era India, through the engineering feats at Baalbek and Puma Punku and the Longyou caves, what the evidence consistently shows is a species of extraordinary capability, a species that was, in its essential cognitive architecture, no different from us. A species that was creative, systematic, curious, practical, and capable of remarkable achievement when the conditions aligned to support it. We owe those people something. Not our credulity, not the willingness to believe impossible things about them simply because the scale of their achievements astonishes us, but our attention, our respect, our genuine curiosity about what they knew and how they knew it, our honesty about what we do not yet understand of their world, and we owe them something else as well. We owe them the acknowledgement that when we lose what they made, when writing systems are silenced, when craft traditions are broken, when engineering knowledge is carried away by the collapse of the civilizations that held it, the loss is real and permanent and matters. The Rongo tablets speak of a loss like that. The Baghdad battery speaks of a question that cannot be definitively answered because the people who could answer it are long gone. The Baalbek monoliths speak of engineering knowledge that, if it existed in the specific form that their construction required, did not survive the fall of the civilization that possessed it. What we have in all these cases is the objects, the stones and the tablets and the cups and the pillars, the marks on the cave walls and the wear patterns on the game boards. These are the physical memories of the ancient world, imperfect, partial, sometimes misread, sometimes misrepresented, but stubbornly present. They are here, they have persisted, and they are still speaking in the only language available to them, the language of their physical substance, their form, their composition, their age, their distribution across the landscape of the past. The question is whether we are listening carefully enough, whether we are asking the right questions with sufficient rigor, whether we are bringing both the honesty to acknowledge what we do not know and the discipline to distinguish what the evidence actually shows from what we wish it would show. Because the truth about the ancient world, the actual truth, the complicated, partial, always provisional truth that careful scholarship is slowly accumulating, is more interesting than any of the alternatives. More interesting than the ancient alien narrative, which flattens the genuine achievements of ancient human beings into evidence for external intervention. More interesting than the dismissive narrative, which waves away genuine mysteries with a confidence that the evidence does not support. More interesting than any simple story, because reality is never simple, and the past, vast, dark, partially recovered, full of voices we can almost but not quite hear, is the most complex and fascinating thing there is. We began this documentary with the image of an object that should not exist, an object that carries in its material substance a challenge to what we thought we knew. And we have traveled over the course of these 2 hours through a landscape populated with such objects. Some of them dissolved under scrutiny, revealing themselves as ordinary things misread by wishful eyes. Some of them remained stubbornly mysterious, defying easy explanation. Some of them proved to be evidence of ancient human capability that exceeds our prior assumptions. And some of them, the Rongo tablets most poignantly, turned out to be evidence of something entirely lost, a voice that spoke and was silenced before anyone thought to listen. What connects all of these things, what makes them worth gathering together into a single documentary and examining with the care and time we have given them, is the way they all orbit the same central question. What were human beings doing in the ancient world, really? What did they know? How deeply did they understand their materials and their environments? How sophisticated were the systems of knowledge they created and maintained? And how much of what they knew and made and achieved has survived, and how much has been lost, perhaps forever? These are not questions with simple answers. They are not questions that any documentary can fully resolve, but they are questions worth asking, questions worth spending time with, questions that the evidence of the ancient world keeps pressing upon us whether we invite it to or not. The stones at Baalbek press the question. The tablets of Easter Island press it. Cup in the British Museum presses it, glowing green in reflected light, glowing red in transmitted light, changing its nature with the angle of view. The pillar in New Delhi presses it, standing dry and uncorroded in the monsoon rain. And now in laboratories and universities and museums and archaeological sites around the world, the questions are being pressed back against with new tools and new determination. Radiocarbon dates are being refined. AI systems are learning to read ancient wear patterns. Genetic sequences extracted from thousand-year-old teeth are mapping the movements of ancient populations. LiDAR scans are peeling back the forest canopy to reveal ancient cities. And somewhere perhaps a researcher is staring at a sequence of Rongo symbols and beginning to see, just beginning to see, the ghost of a pattern that might be the beginning of a key. We do not know, we cannot know, but the not knowing is not a failure, it is the condition of honest inquiry. An honest inquiry followed faithfully wherever it leads is the only path that has ever actually taken us anywhere worth going. The ancient world is waiting, the stones are waiting, the tablets are waiting, the silent marks on the cave walls are waiting, patient as only 30,000-year-old art can be patient. We are learning slowly to listen, and what we are beginning to hear is extraordinary. Thank you for joining us on this journey through the shadows of the ancient world. If you found value in this exploration, in the careful examination of these mysteries, in the balance between wonder and rigor, in the commitment to following the evidence wherever it leads, please let us know your thoughts in the comments below. We want to hear from you. We want to know where you are watching from, what time of day or night you are spending with these questions. which of the artifacts and mysteries we have discussed has captured your imagination most powerfully, and what questions you are left with. Because the questions you are left with are the important ones, they are the ones that will keep this conversation going. They are the ones that, when enough people ask them with enough care and enough rigor, eventually get answered, not always in the way we expected, not always with the answer we hoped for, but answered, added to the growing body of what we know, incorporated into the ever-richer picture of a human past that is stranger and more magnificent than any simple story about it has been able to capture. Subscribe to the channel and stay with us, because there is so much more to explore. There are ancient maps that seem to show coastlines that should not have been known when they were drawn. There are astronomical alignments in ancient monuments that still generate genuine debate about what was known and when. There are medical texts from ancient civilizations that describe treatments we are only now confirming have genuine biochemical basis. There are mathematical achievements in ancient cultures that extended beyond what the conventional narrative of mathematical history has generally acknowledged. The ancient world is not finished with us, and we are not finished with it. We will see you next time.